Good morning, Doctor. Today, our group 1 would like to present our journal, which is the impact of financial risk on financial investment in infrastructure based on the two-factor stochastic differential equation. In this slide, it shows that we have 6 parts that we would like to present, which is the introduction, problem statement, objective, methodology, result, and conclusion.
In terms of financing and private engagement, infrastructure is a fast-growing industry. When seeking capital to finance a project, lenders and equity owners will consider the project's cash flow as the source of their return on investment. Still, the investors may face risks, such as interest rate risk, which is a key concern. Lenders, particularly financial institutions, may suffer from any change in interest rates. The inflation rate risk, however, occurs when the central government supports infrastructure by replacing government appropriations, such as loan payments from banks. This may end up with substantial deficits and non-performing bank loans.
Our problem statement is risk exposure faced by investor, lender, and sponsor when funding international infrastructure projects, and rest about inadequate and excessive government financial investment in infrastructure projects. We got to an objective, which is to conduct research into government subsidies for operating loss under the condition of an uncertain inflation rate and interest rate. The second one is provide an effective tool for quantitative simulation and risk sharing in public-private partnership projects.
Now we will go to the part methodology. In this journal, we will use 5 formulas, and this slide is show the 3 of them. And then in this slide, it will show another 2 formulas, which is the discount operator and the inflation operator. The combination of the 5 formulas that explained just now will form the final formula, which is shown in this slide.
Hi, I'm Xin. In the application of the government subsidy model, I will expose the basic information of project, data resource, and parameter estimation. The project name is NCD Metro Line 3. The project's civil construction began around the end of 2016 and to be operational by the end of 2020. The line's approximate total length is 28.34 kilometers. The project has received about 21.585 billion CNY for the investment. Let's move to data resource. In this study, the local government data was chosen from China bonds with a sample size of 2,402 taken from WIN database. The data selection period is between 4 January 2010 and 2 January 2020. One period of lagging CPI data is employed with the formula shown in the slide. By using the rolling regression method, we are able to observe the changes in the related parameters over a long period of time. The figures shown in the slide express the changes of the parameter in the inflation rate and the interest rate. The tables shown in the slide represent the regression result for inflation and interest rate. The estimated results lead to the conclusion that the inflation rate parameters are significantly different from the interest rate parameters. In this study, we use the difference between the yield to maturity of local government bonds in 1 year and 0 year as the risk premium of interest rate. The figures in this slide represent the time series data of interest rate and inflation rate risk premium. Overall, the estimated values of each parameter using the government subsidy calculation formula are listed in the slide. This formula can help the government in making decisions of infrastructure projects.
Hi, I'm Janice Lee Jiehui, and now I will continue with the numerical simulation. These two curves have comparable growth patterns, showing that the simulated value and the actual value can be quite similar. Thus, we can use the simulated value to predict the future value using data from the past. The cumulative inflation risk that social capital will bear ranges from 0% to 20%, while the government will bear the remaining inflation risk. Based on figure 7, the second derivative 0 point lies approximately between 0.2 and 0.3, meaning the government and social capital will be responsible for a 20% to 30% inflation risk for social capital. It reduces the government's exposure to risk without making social capital intolerable. Based on figure 8, the government's operating loss subsidies decrease as toll adjustment frequency increases. This shows that the government's operating loss subsidies are affected by the frequency of tolling adjusted for inflation. Attached figures show the present value of subsidies as based on R, I, sigma I, and sigma R, where R is the interest rate, I is the inflation rate, sigma R is the interest rate volatility, and sigma I is the inflation volatility. For A, the inflation rate has a bigger impact on the operational subsidy than the interest rate. For B, it is more sensitive to inflation volatility. For C, it appears to be more sensitive to interest rate volatility. Lastly, for D, it is more sensitive to inflation volatility. This shows that the volatility of the inflation rate has the most significant impact on the present value of subsidies.
In conclusion, we are able to show that the impact of changes in the inflation and interest rate on the project's operating loss was correctly predicted by the dynamic random discount rate. Secondly, the social capital inflation risk sharing and the current value of government subsidies are inversely proportional. Thirdly, interest rates are positively correlated with the present value of operating loss subsidies, but negatively correlated when the subsidies are adjusted for inflation. In conclusion, when evaluating financial value as affordability, local government should pay more attention to controlling interest rates and spreading inflation risk between the government and social capital. That's it from us. Thank you for watching.